Okay, this next probability example is going to be a little bit tricky. I'm going to use a tree diagram strategy throughout these problems, and there will be one for you to try on your own to make sure you get it. So in this context, suppose 5 out of 1,000 people are cocaine users. The test is accurate 97% of the time with users, and it's 99% accurate when given to non-users. So at the end of the day, we're going to calculate what percent of people who test positive are actually cocaine users. Because believe it or not, it's possible to test positive and not be a cocaine user and some other scenarios. So we're going to break this down into users and non-users. This is the first stat I got there. So we have users and non-users. Okay, so the probability of being a user is 5 out of 1,000. Or 5 out of 1,000 people are users. So non-users would be the rest. That's 995 over 1,000. Okay, now I started with this because the other data breaks down into these categories. So the user category and the non-user category. So breaking down the user category, two things can happen. You can test positive or you can test negative. And the same thing can happen for non-users. You can test positive or negative. And we're going to look at the probability for those. So if you're a user, it's accurate 97% of the time, which means you test positive 97% of the time, which means you would test negative 3% of the time. And for non-users, it's 99% accurate, which means you test negative 99% of the time and positive 1% of the time. Okay, so using this tree diagram and kind of organizing it this way kind of helps categorize what we're looking at here. So this is the tough part. What percent of people who test positive are actually cocaine users? So I like this tree diagram because we can see where that happens. So we're looking for people who test positive, which is either this or it's this. But it wants the percent who are actually cocaine users. So I want to go back to the idea that's probabilities, what you want out of the total. Okay, so in this case, the total is people who test positive. But what we want is the percent that are actually users. And this tree diagram can kind of show you where that happens. So to actually put our numbers in, there are two cases where people test positive. I'm going to start with the denominator. There's this case and this case. So the first one, 97% of users who use cocaine test positive. So it's not just 97%, but it's 97% of this. So the way we find that is we multiply 97% by that 5 over 1,000, because 97% of them use. Okay, the other scenario is you can be a non-user and test positive. And that's 1% of people, which you write as 0.01. So 1% of the 995 people would test positive, which would be very unfortunate, but small chance that would happen. Separated them so we could talk about what sign would be in between. In this case, we need to add them. Think, why would we add? Okay, the first way to think about it is that the pool should get bigger. If you multiply, the probability to get smaller, but you're actually adding this group with this group. Or you can think about it as these things are separate events. You've got users testing positive separate from non-users. Now for the numerator, we want the actual users. But more specifically, we want the actual users that are in this group that test positive. So the actual users that test positive is 97% of the 5 out of 1,000. So not just the 5 out of 1,000, but it's the 97% of them that test positive. And that's how you'd calculate the probability for this one. So I'm going to pause, put all this in my calculator. Make sure you use parentheses if you're going to plug it all at once. Otherwise, I'll probably calculate each part separately. I'll come back with the answer. Okay, so with that all calculated, you can see my work. I got 32.77% approximately. Or approximately 33%. So that's what percent of people who test positive are actually cocaine users. So then you can also figure out what people who test positive are not cocaine users, which would be unfortunate, but it does or could happen. leave this one for you to try on your own. It's very similar structure. And I'll come back with the answer in a few. No cheating. Okay, here's the answer to the last one. Double check your work with mine, and please come with any questions.